Hello, my name is Taylor Brown, and here's my OU1 account. Here's my exercise 1, network A. I have a resistor, R1, in series with R2, and then R3 in parallel with R2. I have that set up right here. And then I have the voltage source connected to it. It's set to 1 volt. And I'm measuring the voltage across R1. And I have 581 millivolts. Okay, the voltage across R2 is 0.464 volts, which is pretty close to our estimated 0.442 volts. And now we're going to measure the voltage across R3, which was calculated to be the same, 0.442 volts, and it's measuring at 0.464 volts. Okay, I just measured to see what voltage I need to supply my circuit with 10 milliamps. I had it being measured right here. This is about 10 milliamps, and that corresponded to 3.6 volts from the power supply. Okay, now I'm on exercise 2, and here I'm measuring the voltage of the node E1. I have it connected to my E1 line right here, and then I've turned off this voltage source right here. So I've just made this a wire and connected R1 to ground. This is R1 right here connected to ground. And then I'm measuring the voltage across the node E1 by setting up my positive clip of my multimeter to E1 and my ground one to ground, and I'm getting the correct reading of -5 volts. Alright, now I'm measuring the node voltage of E2 right here. I have my positive clip now connected to my E1 node, which is right here. And this time, I just did it with this voltage source turned off and this one on. Now I have this one on and this one off. So now my R1 is connected to power, and then my E1 is just connected to ground. So this is my E1 wire right here, it's connected to ground. And so here I got -3.2 volts. And then the other way, I also got -3.2 volts. All right, now I'm measuring the voltage of the E3 node. I now have the positive clip of my multimeter, or the power clip, connected to my E3 right here. Lines up with where the blue is right here. And then I have my ground clip still connected to ground. And in this specific part, I have this voltage source turned on. So now my R1 is connected to power, and my E1 is just a wire going to ground. So E1's at ground, R1 is at power, and this is what I got. Okay, this is exercise 3, and we are finding the power across this 15 ohm resistor. So I have it right here. We don't have the 4 or 5 ohm resistors, so I made them using parallel connections. So the 10, the 12, and the 15 ohm resistor here are all in parallel, so their equivalent resistance is 4 ohms. And then here, these 2 sets of 2 10 ohm resistors, each one has an equivalence of 5 ohms. So I've used that to create new resistances, and I basically made the circuit, and I am supplying it with a volt of power, and I'm measuring across this 15 ohm resistor. I'm measuring for the current and the voltage so that I can calculate power, and I have found the voltage to be about 0.6 volts. I have 569 millivolts, and that pretty much lines up. This is not correct yet, but it lines up with the 0.6 that I calculated. Okay, and now I'm still in exercise 3. Now I'm just finding the current across the 15 ohm resistor. So yeah, I have this set up to find the current across this resistor. I broke the circuit so that I could do that, and I'm getting 35 milliamps. and I was calculated to get 40, so a little bit off, but it's almost there. Okay, I'm currently on exercise 4, and since we're working in DC, I can disregard these capacitors here. So I have constructed my circuit here, and I have it on Tinkercad right here, so I just constructed it right here, and yeah, now I have 2 voltage sources. I have one that I've connected right here, and then one that's connected like within the circuit. So I have my power supply set to give 3 and 4 volts. So I have those in the circuit, and first I'm measuring the voltage across the RL, and I have measured it to be 184 millivolts, and I calculated it to be 183 millivolts. Okay, so I'm still on exercise 4, and now I'm measuring for the Thevenin voltage for the original circuit. Here is my original circuit, and I've hooked everything up. I'm measuring the Thevenin voltage, so I removed RL, and I'm measuring the voltage between the open circuit. So I'm supplying 3 and 4 volts, and I'm getting a measurement of 3.489, and I calculated 3.48 volts. All right, now I'm measuring the Thevenin resistance. I still have the RL removed, and I've turned all my voltage sources into shorts, into just wires, and I'm getting 17.6 kilo ohms, and I calculated 18 kilo ohms. Okay, now I'm measuring my my Norton current. I've removed my RL and created a short circuit, and I'm measuring the current, and I measured it to be 0.2 milliamps, and I calculated it to be 0.193 milliamps. Okay, here's my Norton resistance. I have shorted all of my voltage supplies, and I'm measuring the resistance between the open terminal, and I have measured it to be 17.6 kilo ohms, and I calculated it to be 18 kilo ohms. Okay, here I'm measuring the Thevenin equivalence voltage. So I've made the Thevenin equivalent circuit right here, and I'm powering it with 3.5 volts, and I'm measuring 0.184 volts, 184 millivolts across RL. And I calculated 183 millivolts across it. All right, now I'm measuring the current across the Thevenin equivalent. So I still have the Thevenin equivalent here. I've broken the circuit here and connected the other node to ground, and I'm measuring 0.19 milliamps, and I calculated 0.1831 milliamps.